please address?
Thank you.
Okay.
Sorry. So you might have been expecting one of my colleagues, Dr. Kinshuk Maitra. I'm Winifred Elise Newman. I'm going to be doing it instead. We have a bit of a switch up. But it'll be easy because it's all something that we've worked on together. So let me introduce first the team. And I'm going to do this because I want to address two issues. One's research and one is education. So the majority of the investigators are also teaching as professors. And one of the first things we did in order to develop the language that we would enable us to do the research was to teach together. So I'd like to underscore that for a minute. So we offered courses for occupational therapy students and architecture students in conjunction. They were given to master's students in both cases, and it worked within what is called a lockstep program for occupational therapy. It was offered to them at a fairly advanced level, and for architecture students, it was offered as an optional course, as a professional education offering. So one of the things we noticed immediately was, and remember, that's a kind of experiment too, right? Offering a course out of the blue with two very different cohorts. The question for us was, what do they offer? What do they offer to each other, these two disciplines? And the lessons learned were pretty significant for us. One was that occupational therapy students certainly understand the physiological body, right? They're looking at disease etiology. They're looking at performance from the standpoint of the person, right? So this physical. And for occupational therapy, remember, they're looking at instrumentalized activities of daily living. So engages the cognitive, which is critical in the end for some of the questions we asked. Architecture students actually see patterns of behavior. So one of the things that happened early on was they walked into someone's home. Occupational therapy students did a lot of instruments, right? Survey instruments to understand mental functioning, cognitive functioning. Architecture students looked at the way they lived. Just what did it look like? What were the patterns? Oh, that's where you left the books. Ah, you're sitting in that chair all the time. You've turned it this way. You've done this. All those little sort of habit trails that we make. And in the end, that's where our research landed. It's actually in the differential between what is the physiological and the cognitive and what is the environment around you. So if I could ask you all to stand up. Did anyone's brain explode? No. But you're seeing the room from a completely different point of view. In fact, none of the geometries that are currently hitting the surface of your eyeball are the same geometries that they were just a few seconds ago. Yes? Why have you not gone crazy? Why are you able to process that change? We don't know. You can sit down. This is actually the challenge. Right? The world that we see physiologically, the world that's coming to us through our senses, is not actually the world. Now, architects have known this for a long, long time. So we have a whole series of works that I can look at, which aren't really critical here, but I can explain briefly. We play all sorts of optical tricks with you. We make things look as though they're larger, smaller, right? Hotter, colder. We can do all sorts of things to trick your senses. And just because your senses can be tricked means that the processing of the data that you're receiving is occurring somewhere between the moment that the data hits your body and the fact that it is processed through your brain, which actually is about 1/30 of a second. We even know how long it takes. What we don't really understand is the differential. We don't really understand why it is that that happens. And as you change physically, and we all do, right? We all do. As we change physically, meaning as our sensory apparatus change, the way we perceive the world changes. So our question fell into a specific category of users because what we were really interested in understanding is some of those changes and how the environment could adapt to you. So there are different ways that this can work in terms of the technology and the relationship of technology to space or to environment. And I'm going to be particular because we can't really measure space. I want to be very careful with that word. What we can do is measure what we perceive of the space, okay? That we can try and try and understand. So if you're wearing a pair of glasses, you're augmenting your capacity to view the world. If you use a cane, you're augmenting your capacity to move through the world. If you can run a marathon, you've augmented your physical capacity to move at a particular speed and length through the world. Our question was, as we age, and we are, and the statistics are pretty significant, so we've moved from what was at one point the kind of, simple column to what's now understood, the pyramid model, it's often referred to the kite or the pillar, meaning that for the first time in human history, adults 60 plus years will reach 2 billion. By 2030, the number of people over 65 will outnumber the number of children in the United States. So looking at how our environments change in order to adapt to us is a critical question. The other one is that it turns out, and there's a lot of medical evidence to support this from the health sciences and the medical profession, that if you can age in place, you're going to be happier. I don't even need to really cover why that's true. I'm sure all of us in this room can understand that. We've all dealt with either a loved one who has had to go into a facility. We know what that can be, sometimes positive, sometimes negative, but certainly change, and change can be difficult, particularly as your physiology is changing at the same time. So having you enable you to age in place becomes a critical issue. So the ICF suggests, through WHO, this was in 2001, they came out with a kind of model that they established saying that these things are related. Disease or disorder, health condition is related to bodily functions, activities, participation in a kind of bubble in itself, underscored by environmental factors and personal factors. So examining for us, the first thing was, well, we could examine those associations. So we said we can look at, and spatial configuration here means layout, right? And we're using space syntax, and I'll explain that briefly, but you really don't need to understand it. To just understand that at a very simple way, we started with saying, hey, let's just look at the space that you're living in and try and put some metrics to it to understand that there's a relationship between that and your ability to perform certain tasks of daily life. So that was the place we started, but then what we really started asking was, well, these were divided more broadly, looking at it as functioning and disability, and then contextual factors. And I actually think for ICF, when they said environment, what they were thinking of was things like air quality, access, mobility, all of those things. So this is a sort of misinterpretation in some ways of ICF that we found productive, because what we really started thinking about was space syntax. And space syntax, most briefly, is to say, look, the way the space is configured has culturally determinative functions, right? So I'll just give you the briefest example because I think it's the simplest. If one imagines a rectangular table in the Western world, and it is important that we make cultural distinctions here, and I would say probably for the past 400 or 500 years, what I'm going to say is stable. Before that, I don't know, because I think it's historically also contingent. So if I take a rectangular table and I want to know what's the most integrated part of the table, in other words, where are you the closest to everyone, it turns out it's in the center. I can do a mathematical test and figure that out. So if you're sitting there or there, that means you're equally close to everybody. Now, if I want to give you the power position, meaning that you are metaphorically and literally the most distant from everybody at the table, where do I put you? At the ends, right? So that means that there's a cultural overlay to what is a geometrically organized space. This is actually what the real difficulty is in trying to understand when we're asking cognitive questions, which we tend to think of as right? Questions that are performed by neural synapses and, right, that are in the body. Trying to ask those questions in relationship to space, to relationship to an environment, proves really, really, really difficult. I mean, you can hear that. It's like there's always going to be a kind of gap between those two things. So part of what we're trying to do is bridge that gap by saying, look, there are neurocognitive, there are things that are happening neurologically, physiologically. We're going to ask you questions using tested instruments and surveys about that in relationship to your social participation, right? We have some pretty stable term instruments to use to determine whether you perceive yourself as active in a social setting, right? As though you're a participant. And that happens to work in a more recent taxonomy model. This is provided by Levasseur in 2010. It's an important one in terms of a continuum. So from doing an activity, connecting with others, all the way out to contributions to society. What we said is that there's a kind of spatial analog to that underlying it, which relates to your body functions and structures, and being able to ask meaningful questions about that using survey instruments, comparing those questions that were environmentally dependent on then spatial configuration environmental instruments might actually give us some data. So we worked with an organization in Atlanta. So far we've done 29 homes. We've analyzed them in terms of their space syntax, and then we've also used the instruments. We've used, in fact, 8 instruments provided through occupational therapy to ask questions about their cognitive well-being. Then we've said, what questions related to things that were part of social participation? In other words, what parts of your mental cognitive activity were you depressed, therefore not leaving your room? Were you able to perform certain cognitive activities? And would that have an effect? The average age of our residents was about 60 years. We've only done 29. It's a very, very early part of the study. We need significantly more people. And good for them, most of our participants are functioning. In other words, they're able to perform activities of daily living, both instrumentalized and not, fairly well. So we don't actually have a population yet that would start needing for the environment to respond to it. What we found was that certainly in terms of space connectivity, I can briefly tell you what this means. The larger your house, the more connectivity you have, meaning the more doors you have to go through to get someplace. This relates also to what's called the depth mean. It turns out that people with more doors and more connectivity, who also turn out to have more money, surprisingly, right, tend to perform higher in MoCA scores. MoCA scores are an activity of your mental capacity, but the MoCA scores were not significant in this case in terms of the differential. So nothing particularly, and here's there, I'm gonna go a little faster. So scatter plot to show that. Turned out that we could predict, in effect, based on your income, your age, and your MoCA score, how large your house would be. Useful in certain ways, but not surprising in another, right? I have more money, I can buy a larger house. So then what we did, just to show you how, then what we ask is, can I predict loneliness using social participation? In other words, can I ask, and we did, if takes so many steps to get from one room to another, can I predict the amount of social activity in your daily life and therefore relate that to an idea of loneliness? It turned out that it broke the model. It turned out that our assumptions were incorrect. That the people with higher self-reported loneliness actually lived in smaller houses. What we're surmising, and again, remember there's a strong cultural overtone to this that cannot be underscored enough, but what we're surmising is that in this environment, in this place, the United States, in this particular community, that if you have a larger home, in fact, you may be able to entertain more. Right? So that, in fact, may explain why you really don't feel lonely. You see how difficult this is. We've got data, I can point to effects, we can try and predict, but what we're really looking at is that kind of space between what is my perception of the environment and how the environment needs to perform in order for me to, be able to do things. Now, I can give you the history of architecture in 10 seconds. Quickly, because I want to make one final point. Here are the things we wanted to do. Here's the history of architecture. Now, the reason this is because we start out here building structures whose wall thicknesses are, on average, 30 meters, right, 20 meters, 10 meters, right? Think of the pyramids, think of Egyptian architecture. Slowly, slowly, what we've done is actually thin that, right? So that now we're here somewhere. You can see it at the structure that we're in. Much thinner walls to perform and do what we need to. We've embedded technology in those walls. The next step is to embed that technology here and here. Once we do that, I won't be working with just a physical environment as a designer. I'll be working with the virtual environment as well. It's not that the virtual environment is a simulacra that I use to design this. It's that the virtual and the real work like this. So I'll be able to design sensors. You have Alzheimer's or you have Parkinson's and you have difficulty moving. I'll be able to design sensors that are GPS coded to your space that will make you feel something, right? That will put pressure, that will show you something visually, that will augment and enhance the environment that you're living in so that you can perform activities of daily living. This is why the neuroscience component is important. Because if I don't understand what you need, if I don't understand how that percept works, if I don't understand what the physiological component is that needs to be stimulated in order for you to perceive that environment the way I want you to, all is for naught. I can't do it. It's already happening in our environments if you use your phone for anything more than calling people. Your brain is already in 5 different places at once. The question is, how do we begin to manage the design of those places so they augment us to be able to perform in them? So that's the challenge we're trying to address. As I said, we've started very small. Thank you for your time.